Welcome back, happy learners. Here we are on Desmos, desmos.com. I've typed in capital F of x equals 2, and then you can type in int for integral, or you can find it from the keyboard under functions, miscellaneous, and then integral. Integral lower bound a, upper bound little x, integrand little f of t, dt. Then it's prompting me to add a slider. I'm going to let the lower bound, a, be a slider. And for f, I'm going to make a definition of integrand f as x, so linear x. And you might know that when you integrate x, you get x squared. So we've plotted out, or Desmos has plotted out, in red, x squared, plus a constant. And then the constant depends upon the choice of a, since capital F here is defined as a definite integral. All right. Let's type in a new line, min of, open parentheses, the value of 0 and the value of f of x. So take the smaller of these two, less than or equal y, which is just any y that's going to correspond with any x, less than or equal to the maximum of those same two quantities. All right. And then after that, type in open curly brace, a, and then less than or equal to lowercase x, less than or equal to capital X. And then it's prompting for a slider capital X. We want to introduce a slider capital X. And when we introduce that slider capital X, we're going to use it to plot out points x, comma, capital F of x. All right, so let's ask Desmos to introduce a slider. All right, and there it is. Now, we have a purple region shaded in our graph, and that purple region is going from the, vertically, going from the x-axis down to the graph of f, y equal x. Right? And then we have a red dot plotted at the coordinates capital X, comma, f of x, where capital X is set equal to 0. So if we look back at what capital F of x is, it's going from some a value, which is negative 1.84. It's going from a up to x, which here, little x is taken to be capital X, and capital X is 0. So in other words, the red curve evaluated at input x equals 0 produces the shaded purple area. Good. Now, the red dot we can see, thank you Desmos, is telling us that the shaded area corresponds with a value approximately negative 1.6928. Right. Nicely, we can hover over this dot and we can select it if I click, and then if I move to the left. So as I'm moving to the left, obviously the x and y coordinates are changing, but also notice that the shaded region is changing. Note as well that the y coordinate for the red dot, as I move x's left, gets smaller, and that's corresponding with a smaller shaded region. So when I take this dot such that capital X is equal to a, let's type that in, negative 1.884, what do we get? We get an output of 0. Good. Let's zoom out a little bit. Let's hit play on the capital X. It's a little bit fast. Let's slow that down. Slow that down quite a bit. Come back. Let's do negative again. Negative, and then hit play and watch it. Let's pause here. So the input is near 0. And note that when the input is 0, we're going to be at the vertex of the parabola. And in terms of shaded area, we've shaded as much as we possibly can, moving rightward, underneath the x-axis. And then as inputs move to positive inputs, that the purple region is going to begin to shade underneath the green curve and therefore lie above the x-axis. Play. There we go. So now we're shading above the x-axis, which is counterbalancing what we've already shaded underneath the x-axis. And then by changing the A value, changing A is determining where we want to begin shading underneath the green curve. Right? And then shading underneath, well, here we're clearly not shading underneath, we're shading between the curve and the x-axis. So if the curve happens to fall below the x-axis, we shade from the x-axis down to the curve. If the curve lies above the x-axis, we shade from the x-axis up to the curve. Very nice. Hit play. All right. And hit play on X. And there you go. So this is the fundamental theorem of calculus.